All right, in the second part of 5.4, we're going to look at the second case of law of sines, where you can find the angles of the triangle it's missing if you have what's called side-side angle. So you have two sides and the non-included angle. So remember the angle that's not in between these two. Now the reason why this one's a little trickier and has different cases is let's just draw a scenario here. So I'm going to draw some angle. So let's say I know some angle. Let's say it's 20 degrees. I know it's not a 20-degree angle, but let's say that's what it is. So that's an angle. And then I'm going to have two sides that are not in between this angle. So I'm going to have this side here. So let's say this is 10. And then I'm going to know the side length of this next side, whatever it may be. Let's say it's 7. Now the problem is there are lots of scenarios where if this side length is not long enough to touch straight down here, then we don't even have a triangle. If that side length does not touch that bottom line, and this bottom line could be as long as you want, then we don't have a triangle. There are other cases where if this side length is just the right length, maybe I can put the side length like this, or I can put it like this. That's going to give me two triangular solutions. I have this one on the outside, and then I have this one on the inside. So there are lots of scenarios where you can have one triangle solution where you have three angles and three sides, or sometimes the dimensions you're given actually can lead to no triangles or multiple triangles. The way we can determine this, though, is we have to do is really figure out what is this distance here. And whatever our side is in comparison to this side right here, which we'll call h, we can determine how many solutions we have. Now the good news is this h has a formula. So this h, which is the length straight down, h is going to equal b sine a. Or it could equal a sine b, or any really side, or it could be c sine a, or it could be c sine b. It just depends what letters you're given for your variables. But it's basically the side times the sine of the angle you're given. And it's the opposite. So what we know is we never want this and this to be the same letter. So they have to be different letters. So there are four scenarios here. There is one case is there's no triangle. So if A is less than h. So A is going to be our third side. So we have an angle, right? So we have an angle, say A, and then a side B, and then we have this other side. So really everything's determined on this second side that is the same letter as the angle we're using. So this is A, so this would be little a. If A is smaller than h, and h again is this B sine A, then there's no triangle. It is not long enough to touch that bottom line, so it is not a triangular solution. If A is equal to h, if A basically is straight down, then you have one triangle. That's not really as big a deal, but it could happen. Doesn't happen very often. The fourth case, we'll come down here real quick, we always have one triangle if A is bigger than B. So if A is bigger than B or equal to B, then you have one triangle. You have this bigger triangle here. The one that's tricky is this one. If A is bigger than h, but A is less than B, then you have two triangular solutions. So this little chart is very important because it's going to tell me how many solutions I have. If I have one solution, it's no problem. We just solve the angles, we solve the sides, just like we did in the previous problem with a little switch. If there are no triangular solutions, then we're done. We just say, okay, we're done. No triangular solutions. If there's two, then we have to find two sets of angles, two sets of sides. It takes a little more work. So let's go ahead and look at a couple examples. I'm going to try to draw a picture, and then I'm going to try to use the formulas that we had on the previous page to help me figure out how many solutions I have. Now, what I would always do is I would always first start off by finding h. And h in our case is going to be b sine a, because the angle we have is a. So in this case, that's going to be 12 sine of 25. So h is going to be 5.07. So if we think about what's happening here, we have this side here. We have a 25-degree angle. So that's angle A. So this would be side B, and side A would be across from angle A, and it's 13. So here's our setup. So the question is, does 13 really touch? Well, there's definitely going to be a solution because 13 is definitely bigger than 5.07. There's only no triangular solution if A is smaller than that value. So we definitely have one. In this case, we're actually in case D. A is greater than or equal to B, so we only have one triangular solution. So in other cases, you'll have two triangular solutions. In this one, since A is greater than or equal to B, definitely greater than, we say there is only one answer. So we only have to find one set of angles and one set of sides. So all we have to really find here is we want to find side B, or angle B, angle C, and side C. So I'm just going to write that up here because this is what we have to find. We have to find angle C, side C, and little angle B, or big B. So, since the information I have in our law of sines, I have sine of A over A, sine of B over B. I'm not going to use C because I know absolutely nothing about C right now. I don't know its angle, I don't know its side, so there's not much I can do with it. But I do know stuff about A and B. I know angle A is 25, so I could say sine of 25 divided by side A, which is 13, equals sine of B over 12. So our goal here is to solve for angle B, because that's the variable. And you can see it's kind of inside the sine now. So we'll have to go back to some of our geometry theory to get it outside of the sine. So first thing I'll do is I'll get the sine by itself. So I'm going to multiply both sides by 12. So I'm going to end up with sine B. Now I'm just going to put all this in my calculator. 12 sine 25 over 13 is just a decimal. So it's 0.3901. That's just by putting it in the calculator. So now we have a statement that says the sine of angle B is equal to 0.3901. Well, the problem is the B is inside the sine, so we have to basically get rid of the sine. The way we find the angle is, if we're giving a ratio, is we use what's called the inverse sine. So to find angle B, we will take the inverse sine, which is just a sine with a little -1 on it. It's above sine in your calculator. It's on Desmos. So if I do second sine or inverse sine of 0.3901, it's going to tell me B is 23.0 degrees. I'm just rounding to the nearest tenth for the degree. So that is going to be angle B. So we have part of our solution solved. We have 23. So now, since we have two of the three angles, we can actually find angle C really easily now. Because remember, since this is now 23, I know angle C is just 180. Measure of angle C is 180 minus 25 minus 23, which is 132. So now I have all the angles. So now my goal is going to be, well, let's find that other side. So I'm going to do the same thing. I'm going to do sine of A over A, so sine of 25 over 13. But now I know what angle C is. So sine of C is 132 over little c. So now this is similar to what we did in part 1, where we have a missing side. So we'll cross multiply. We'll get 13 sine 132 equals c sine 25. I will divide both sides by sine 25. So c equals 13 sine 132 divided by sine 25. And that's going to work out to be 22.9. And again, I would encourage you to make sure you can plug this into your calculator, get the same numbers I am. So this is 22.9, this is 22.9, and this angle was 132. So now I have all the three missing sides and angles, all the three missing parts to this triangle that I didn't have at the beginning. Now, this was honestly one of the easier scenarios because there's only one solution. There are times where you'll have to do this twice for a problem. Okay, let's look at a second one. So in this case, we have angle A is 125. So that's a really big angle. So let's try to draw a 125 degree angle for A. So B is 45, so that's 45. So the only way for this to really work would be as if I could make a side that goes here. There's no way I'm going to be able to make a right triangle out of this because 125 is bigger than that. So I'm going to go ahead and find H. H again is B sine A. So in this case, that's 45 sine 125. So if I put that in my calculator, I get 36.9. Well, this actually is good news because in this case, A, which is 35, is less than H. So I'm actually in scenario A. I'm in the first case. So since A is less than H, there is no triangular solution. And this actually makes a lot of sense because if I'm going to get this side to go down here, it's definitely got to be bigger than 45 for side B. 45 is this distance. Well, 35 would only come like to this point, so it wouldn't even go back all the way down, so that it makes sense that there is no triangular solutions. So with these dimensions, there is no way you can have a triangular solution. So it's just no solution. Now the good news is if you try to do this problem and you put it in the law of sines and you work it out, the calculator actually will tell you error. So that is something you want to keep in mind. That you can do it that way, but it's nice if you just use these cases in that chart that we had on the previous page. Look at that, commit it to memory, bring it with you on your note card so you can use that on your assessments. Okay, let's go ahead and look at this last problem. So we have angle A is 25 degrees. So this is 25 degrees for angle A. Side B is 10, and side A, which is going to be this side over here, is 5. So the question is, does this make one triangular solution, two, or none? Well, I'll first start by finding H. H is going to be B sine A. So in this case, it's going to be 10 sine 25. Now 10 sine 25 is simply 4.22. Now in this case, we definitely have a solution because A is bigger than H. So remember, there's no solution if A is smaller than H because it doesn't reach down. But A is also less than B. So this is actually case 2. This is going to imply we have two triangular solutions. So on our picture up here, what that means is it means I could fit 5 in this distance. It would fit just fine. But I could also fit it going this direction. So I have two triangles. I have this triangle here, and then I have this bigger triangle here. So I'm going to have two triangular solutions. So what I'm going to do is I'm actually going to draw two pictures, and I'm going to try to solve them both separately. So I'm going to have triangle 1. I'll make triangle 1 the bigger triangle. It's going to look something like this. We have A, we have 10, and we have 5. And so this, of course, is side B. This is angle B. This is angle C. This is little side A. This is little c. Now for triangle 2, I'm going to make triangle 2, this smaller triangle I have hashed in red, so it looks something like this. So it's going to have an obtuse angle. So we have A, C, and B. Little a is still 5, little b is still 10, and angle A is 25. This is 25 over here as well. So what I have to do is I have to find both these missing sets. Okay? And we'll use law of sines, and then we'll have to add one little thing when you have two triangular solutions, how to find the second one. So I have to find angle C, angle B, and little c here. And over here, a lot of times you'll see texts and programs do something like this. We'll call it C1 or C prime, just so we know it's not the same as above as the other one, just so we can kind of see what it works out to be. So I'll do triangle 1 exclusively, and then we'll come back and do triangle 2, because they essentially will work the same way except for the very first little part, finding the first angle. So I'll use my law of sines. I definitely have both things for A, so I'm going to start with A. So sine of angle A over A equals sine of angle B over B. So I'm going to multiply both sides by 10. So I get 10 sine 25 over 5 equals sine B. And so now to find angle B, I'm going to take the inverse sine of all this stuff from above. You can find the decimal of that. That's fine. So I'm going to get B to be 57.7 degrees. So up here I'll put 57.7 degrees. So now this triangle is relatively easy to find. So now I'll finish this one up. I'll go ahead and I'll find angle C. Angle C is going to be 180 minus 57.7 minus 23, which is 97.3. So 97.3 goes here. So 97.3, 57.7. And so now I just have to find side C. And again, I could do this with a really simple law of sines. So sine of angle A over A equals sine of angle C over little c, and we don't know what little c is, so now we'll do the cross multiplication. So 5 sine 97.3 equals c sine 25 divided by sine 25. So we get 5 sine 97.3 divided by sine 25. So you do enough of these, you start to see how they work out, how they go, kind of a similar pattern each time. So in this case, I get C to be 11.7. So if I go up here, I now have all parts of this triangle. I know both angles that were missing and the missing side. Now the problem is I now have to do this a whole nother time for the other triangle. Now the good news is you don't have to do the law of sines initially and do the inverse sine like you did above, because this angle B that we found, it's actually related to our second B. And the way we find the second B, if there's two triangular solutions, this B is always going to be 180 minus 57.7 degrees. So this one's going to be 122.3. So you don't have to do the law of sines again. We automatically know what it's going to be. It's always 180. It's always its supplement. So 122.3 will go there. So the second triangle is easier to find, but these problems definitely, when there are two solutions, they are a hassle. So now C1 is going to be 180 degrees, because the triangle also has 180 degrees, minus 122.3 minus 25, which is going to be 32.7. So this angle up here is 32.7. And so now I have a new c. So I'm going to go and I'm going to finish it up just like I did the other one. Sine of a over a equals sine of 32.7 over c. 1, because we're looking for c1 in this case, because I now have c, which is 32.7. And so I'll do the same cross multiplication. And so using the same pattern, hopefully you start to see c1 is going to be 5 sine 32.7 over sine 25. So c1 is going to be 6.4. So when you look at this, obviously a lot of work, a lot of things go into solving these, especially when you have two triangular solutions. The good news is most problems either have one or no solutions, but there are cases where you do have these two, and because of the measurements you have, you can have these two cases. Now the good news is this is the only case, the side-side angle is the only case that does this. Angle, side angle, and the two that we'll learn for the law of cosines in the next section, they always only have one solution, so that's somewhat nice. So that's all for section 5.4. If you have questions, obviously, please let me know.